Now we come to system and control volume. When we are considering a certain block of fluid that we want to analyze, we call it a system, and then certainly within that system, the volume that we chose to consider and discuss, and with our discussion analysis that will apply to the whole setup, is known as control volume. This is a terminology that we hear every now and then. In weather forecast, for example, you keep hearing that a system will move into this area of our country or that area, and there will be, as a result, there will be rain or wind or something else. So we use the term system. So what is that system? Is a certain block that is being considered for a fluid or the item that is under consideration. And we are here concerned with only the fluid. A system is defined as a quantity of matter or a region in space. I was emphasizing on region in space more, chosen for study. So you choose it arbitrarily, of course, but that arbitration is chosen in a way that it will apply to the whole area wherever that fluid flow is taking place. The mass or region outside the system is called the surroundings. The real or imaginary surface that separates the systems from surroundings is called the boundary, of course. The boundary of a system can be fixed or movable. So both conditions are possible. One, that is, the system is moving and the boundary is fixed, and another one, when not only that the system is moving, the boundary is also moving. And there can be many examples for that category. Note that the boundary is the contact surface shared by both the system and the surroundings. Mathematically speaking, boundary has a zero thickness, and thus it can neither contain any mass nor occupy any volume in space. But still, we are imagining a boundary that is there. So system may be considered to be closed or open depending upon whether a fixed mass or a fixed volume in space is chosen for study. This is very important. Whether you choose the volume or the mass, but you chose a certain area that is that we want to study and analyze. We give a little example here. A system is defined as a quantity of matter or a region in space chosen for study. A closed system consists of fixed amount of mass. An open system or control volume is a properly selected region in space. You see two pictures here. On the left, we see, for example, if we are heating something, then the gas will expand as its temperature will rise. We can understand that it expands. We know that it expands with rise in temperature. And as it will move its boundary in the upward direction. So here is a case that we are considering the gas or movement of gas, and as a result the movement of the piston, but that is, boundary is changing in that case. And on the right hand side, the gas is fixed and the boundary is not moving, but only, and we are considering the area that is shown in color, and in this case the consideration of a certain volume or mass of gas is chosen for consideration, and it has a fixed value. And a little more about it. When a control volume is chosen, then of course the volume that we are considering and trying to analyze has a certain dimension and limitations, and we attach to it a boundary that doesn't really exist because the fluid flow chosen is within the flow. So there is a flow outside it as well, but we consider an imaginary boundary that does not have any thickness, as we described, cannot contain any mass or volume, but at the same time it exists, and in the picture it is shown with dotted lines. And when there is a real boundary, you can see that it's a solid boundary, solid wall, and during which the fluid is flowing. And in the second case, we have shown here, and in which, for example, gas or liquid can be allowed to enter through a pipe into this utensil, and as the fluid will enter, the boundary above is going to move upwards. So there are many ways in which we can allow the fluid to enter.